This is REWAISE, an European project that's transforming the way we use and perceive water. Across 9 European living labs, we're building a smart, decentralized water management system. We would like to increase the value in, from, and through water. Our goals are clear: reduce necessary consumption of drinking water, recover resources and minerals, and cut CO2 emissions. Because water is not just a resource, it's life. But how can we use it more wisely? In Poznan, one of the fastest desertifying regions in Poland, we're doing exactly that. Backwash water, which was previously considered waste, is becoming a valuable resource thanks to our efforts. Together with Poznan University of Technology, we're developing an innovative system to recover and recycle backwash water from sand carbon filters.
Our station treats underground water containing iron and manganese compounds. After the aeration process, the water is directed to sand filters, which retain this substance. Therefore, our task is to flush the filter approximately every 3 days, which produces backwash water.
On average, we rinse 6 to 10 filters per day. Each filter gives us 250 cubic meters of backwash water, so if we multiply this by the number of filters, we can obtain a maximum of 2,500 cubic meters of water, which is discharged outside the station and is treated as a waste. Our idea is to return this water to the circular economy at the beginning of the technological system. In terms of benefits, first of all, we do not waste water, which with we could supply 15,000 residents every day. Secondly, we contribute to the protection of natural water resources. And thirdly, in the REWAISE project, we wanted to find a technological advantage. Our research involves the process of autocoagulation, that is, dosing backwash water into raw water after the aeration process.
Let us remember that in raw water, iron is at the 2nd degree of oxidation, and in backwash, a small amount of ferrous suspension is at the 3rd degree of oxidation. We didn't know whether adding ferric suspension to raw water would shorten the filtration cycle, that is the time between filter releases.
The results of the research are positive, because the addition of backwash water to raw water did not shorten the filter cycle, but rather extended it by several hours. The experience gained from this research allows us to draw practical conclusions that we will use to develop the concept for this project. This task will allow us to reuse 100% of the water that was previously discarded, which ends up in the sea and becomes salt water. This could have a real impact on the water management of our region. Instead of wasting, we are closing the cycle. During the implementation of the project, we encountered few challenges that revealed how complex the issue of reusing backwash water truly is. The greatest of these was identifying real technological benefits from redirecting such water. To achieve this, a detailed analysis of its quality was required, along with precise integration into existing technological processes. In the research period, we faced another difficulty: the sedimentation of iron-rich suspension in water supply pipes. Over time, this led to reduced flow and narrowing of pipe diameters, which forced us to use flushing with a water-air mixture. Another significant issue was the lack of clear legal regulations concerning backwash water. Without appropriate formal frameworks, implementing innovative solutions becomes considerably more difficult. Despite these obstacles, we look to the future with hope. We are planning to develop a tool that could change the way we think about water, a benefit calculator. With it, water producers will be able to easily assess the potential for reusing backwash water. It's a step toward a more sustainable water management system, a step that could have a real impact on the future of our planet. Join the movement, follow the project, save water, learn and implement with us. The future of a healthy planet lies in circular water, and that future is now.